I don't know why it does that. When I press record, it pulls up like this every time. Okay, on the back, classifying. Triangles. There's the symbol. That's what we're going to use. And what I'm about to talk about will be like a really quick review. Then I'm going to add in a little more higher level math to it. Okay? Alright, we classify triangles by their sides and by their angles. So if you're asked, which you will be often in this unit, to classify the triangle, you should be giving two answers. So for sides, we have scaling. What does that mean?
No sides.
No sides are congruent. Perfect. So I'm going to give you, this is the R level math. Colin, you with me, bud? I'm going to give you a Pythagorean triple. If we remember that, that is scaling. It doesn't have to be a right triangle. I'm just giving you this as an example. This one is a right triangle, which is also a Pythagorean triple. Who remembers what a Pythagorean triple is? Riley. You remember what a Pythagorean triple is? Okay. Tell me. So that's the Pythagorean theorem. What's the triple, Declan? Almost. Quincy?
When two sides add up.
So that always happens in Pythagorean theorem. Pythagorean triple is when we do not get any decimals. When I can say 9 plus 16 equals 25. Remember in Pythagorean theorem, we end up taking the square root. So sometimes we get perfect. Sometimes we get square root of 65. Is that going to give me a perfect number? No. So that's not a Pythagorean triple. But when we get perfect whole numbers, that's a Pythagorean triple. All right, next one, isosceles. How many sides are congruent? 2. Draw it without numbers, please. That's R level. All right, challenge question. Isosceles triangle has 2 equal sides. How many angles in an isosceles triangle do you think are congruent? 2. But why does that make sense? So, if I have this angle, and it is 30 degrees, and I connect the ends of it, that's going to be a certain length, right? If this angle is over here, is that going to change? No. So the side across from an angle will always be the same if the angle's the same. So when we're looking at an isosceles triangle, if these two sides are congruent, we know the angles across from them are also congruent because this pink angle opened up the same amount as this pink angle. All right. The last one, the last classification, do we remember the word? Equilateral. Good job. Equilateral. Draw it without numbers, please. All right, challenge question. What would all 3 angles in an equilateral triangle equal? Raise your hand if you think you know. All right, Jackson. 60, right? Because all 3 angles are opening up the same amount, and they all have to add up to 180. So if they all 3 have to be the same, 180 divided by 3, they all have to be 60. Always. So an equilateral triangle is equilateral, and I'm going to write this on the bottom of my angle classifications, equiangular. So if you have to classify equilateral triangle, it's equilateral and equiangular. Alright, let's add the others for angles. Acute. An acute triangle. How many acute angles will we have in an acute triangle?
2.
Acute. Let's say this is 80. Sorry, that's kind of small for you guys. This one's 60. What would my last one be? 40. Good job. There's an example of an acute. I don't know why I drew that so small. My bad. 2 more to talk about. A right, which we're all very familiar with, has 1 right angle, 2 acute angles. So if these 2 missing angles are both 45 degrees, classify this triangle by sides. What would it be? Isosceles. Why? 45, 45. If we have 2 angles that are congruent, we have 2 sides that are congruent. And our last one, what would be our very last classification for angles? Obtuse. How many obtuse angles could we have? Only 1, because once I draw 1, obtuse, if I draw an obtuse angle, is there any possible way for me to draw a second obtuse angle and make a triangle? Absolutely not. So this guy is a thin little triangle. But you guys were just playing with spaghetti. And we know that if I were able to, right now, if this was spaghetti, if I were able to push this vertex in and line these 2 pieces up with that 3rd side, these 2 sides would be what compared to that 3rd side? Nope. Longer. They have to be longer, right? So the small side plus the medium side must be longer than that 3rd side. These 2 could be equal to each other, so we might not have a small and a medium. We might have 6 plus 6 is 12, and this side over here is 11. But 2 sides must be longer than the 3rd side, right? Triangle. Never have to write the word. Inequality theorem. And to help you remember through the unit, spaghetti theorem. So when I say spaghetti theorem, that's me cueing you back to what that meant. All right, turn it over. Find the measure of each side of RST. I am stopping there. I am drawing RST. When we're done with this one, you might think that was easy. I don't need to draw that triangle to do that. Maybe not, but there will be some that you will absolutely need to draw a triangle or you'll get confused. So always just make it best practice that you do. Label. RS is 2x plus 2. ST is 3x. TR is 5x minus 4. The perimeter is 18, so how can I solve for x? Yeah. Right, add every side up and set it equal to 18. But let's do it at this level of math that we should be at. 2 plus 3 plus 5, I have 10 x's. 2 minus 4 minus 2 equals 18. That's where we should be, okay? So skipping those steps and doing our algebra at a higher level. So I already saw someone hold it up. What'd you get, Peter? 2. That's exactly right. X equals 2. Good job. So determine the type of triangle. So I need to go back and see. 3 times 2, 6. 4 plus 2. All the sides are 6. So classify with 2 words. What would it be? Equilateral and equiangular. Equilateral, equiangular. Okay. Fast as possible. All 3 of these angles are 60, right? Equiangular. They're all 60. All right. I said 10-minute lesson. I'm at 11 minutes, but I just want to give you a pointer on number 2 because my 1st and 5th period yesterday were working way harder on this than they need to. Okay, we're at a point now. We understand these are coordinate points. I understand that I have a triangle ABC. I saw people yesterday plotting these points to find the distance. Please don't do that. That's a waste of your time. We need to be at a point now where if I'm trying to find how long is AB, that I can quickly do the distance formula. Just like I can quickly set this up in my head, watch how quickly we can do this. I know it is the square root of the difference in the x's. So to get from -1 to 6, that's 7. 7 squared. Plus, to get from 5 to 1, what's the difference there? 4. 4 squared. Does it matter if it's negative or positive? No, because I'm squaring it. It doesn't matter. It's going to be positive no matter what I do. So then 49 plus 16, AB is the square root of 65. That's it. I didn't plot points. I didn't do anything else. Because, do I need to turn this into a decimal? Absolutely not. I'm classifying by angles and sides. So if I get another side that's square root 65, this is isosceles, right? Exactly. So that's how we would do it. And then we'll classify it based off of what we get. That's all we have to do. So this was for AB. You would do the same thing for BC and then CA. And just a quick little distance formula. You don't even have to square root it. Just remember that square root stays on it at the end. The hardest math we did is what is 7 squared. That was the hardest thing we did. As long as you know the process, you're good. All right. The rest of this page is your homework. That's due next Wednesday. I don't see you Tuesday. So that's it. That's your homework. It's written up here, classifying triangle sheet. This is what I will check next Wednesday. That's all of it. Okay? Email me if you get stuck and you need help. Otherwise, the rest of class, you may do your art project or you may finish your homework. You can decide.